right, so we're going to talk about exploring angle pairs today. All right, so adjacent angles are two coplanar angles with a common side and a common vertex, but no in common interior points. So here I have A, B, C, and C, B, D are adjacent. So notice they share a side, CB. Okay. Vertical angles are two angles whose sides are opposite rays. Okay. So these are vertical angles here. R and M, P and S. They're vertical angles. So angle 2 and 4 are vertical. Angle 1 and 3 are also vertical. Okay. So to have vertical angles, you kind of have to have this cross of lines. Okay. And those are going to form those vertical angles. Complementary angles. So complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is called the complement of the other. So here in our example here, these are complementary. So this would be a right angle here, and this angle here is complement to the other angle. So they add up to 90 degrees. So here's another example, 50, 40. They're not always adjacent like they are here, okay? As long as they add up to 90, they are complementary. Supplementary. Supplementary are angles whose measures have a sum of 180. Each angle is called the supplement of the other. So we might have something like this, where it's 45, 35. They are adjacent and they're supplement. We could also have something like this, where they don't have any connection at all, except that their sums are 180. Okay. All right, so our CFA, so here's CFA, and AFE adjacent, AFE adjacent. So are they adjacent? The answer is no. Why are they not adjacent? Well, remember, adjacent means they can't have any common interior. So if I look at this angle here, the CFA is that angle right there. If I look at angle AFE, it's this whole angle. Do I have any overlap of color? Yes, so that means they are not adjacent. Our CFA, and DFB, vertical. Well, do these lines continue on? Notice here CF stops at F, so it can't be vertical. Okay, so these are not vertical. Remember, vertical are going to form that nice X pattern. It's not going to be shifted. It's going to form a nice X, okay? So this is also no. Name a pair of adjacent angles. Now there's lots of adjacent angle pairs up here. We're just going to name one. So what I'm going to do is I'm going to pick an angle, AFB. So I'm going to say angle AFB. So that's this angle right here. And I'm going to pick another angle that uses one of those sides. So I'm going to go ahead and pick, this one right here, CFA. So angle CFA. So notice here I have CFA, I have AFB. So you should notice here that I have AF and AF. Okay? So that tells me that those potentially could be adjacent. I look, there aren't any interior angles that are interior points common, so they're adjacent. Name a pair of vertical angles. Okay? So vertical angles, I have to look at that nice cross. So here I have that nice cross happening there. So I'm going to ignore CF right now. And I'm going to look here. I'm going to look at this angle here. Okay, well, here's my angle. So angle AFB. okay? So notice it comes to a point at F. So when we come to that point, vertical says it's got to point to the other one. Okay, so it's pointing towards it. Okay, here's my other angle. Angle EFD. AD is a line, EB is a line. So those are vertical angles. I could have picked EFA and DFB. Those would also work. Name a pair of complementary angles. If you remember, complementary means they add up to 90. So here's my right angle symbol right here. So here's my two complementary angles. So I have angle EFC and angle CFA. So those are going to be complementary. Name a pair of supplementary. So now I just need to take two that form a line. So when I'm looking at these, I want to make sure that I have a line. So notice CF terminates at F. So I either need to use EB or AD. Doesn't really matter which one. We're just going to pick one. So what I'm going to do is I'm going to look at EB here. Okay. So what I'm going to do is I'm going to pick this angle right here. Angle EFC. So I have this angle right here. And now I need the other angle that's going to make it add up to 180. So this is this whole section. Angle CFB. There are a lot of supplementary angles in here. You could have picked any number of different ones. All right. Information from a diagram. In geometry, we need to be able to get information from a diagram. So items we can conclude. We can tell if angles are adjacent from a diagram. Angles are adjacent and supplementary, right? We can tell if they add up to 180 degrees. We can tell if the angles are vertical. Okay? These are items we cannot conclude from just a diagram. They may look like it, but we don't know for certain. Angles or segments are congruent. The only way we know that they are congruent is if in the diagram they physically give us that representation, either by hash marks or arcs through the angle or some other information, not just strictly looking at it. An angle is a right angle. Again, kind of like up here, to make sure this is a right angle, you need to have that right angle symbol. If you don't have it, it may look like a right angle, but it could be 89 degrees. It could be 89.5 degrees. It could be 90.00001 degrees. And so it may look like a right angle, but we don't know unless we have that symbology. And because we don't know it's a right angle, we can't tell if they're complementary unless we have more information. Okay, so here's our diagram. So is angle 1 congruent to angle 2? So we look up here, we find angle 1, we find angle 2. What do we notice here? Well, they each have an arc with their angle. So this would be yes, they are congruent because in our diagram, it gave us those two arcs to show that it was congruent. Are angle 3 and 5 vertical? Well, here's angle 3 here. So if I find here, it's pointing to angle 5. We notice that these kind of cross and form a line. So 3 and 5 are vertical. Okay, so we can tell that from the diagram. Can you name a pair of adjacent angles? Well, I'm going to say angle 3, and then I'm going to pick one that's adjacent to it. Well, I'm going to pick 2, angle 2. I could have picked angle 4. It doesn't matter. Name a pair of adjacent and supplementary angles. So supplementary, remember, adds up to 180. So I'm going to go ahead and pick angle 4. Angle 4. Now, it has to be adjacent and supplementary. So I'm going to pick angle 5 or angle 3, so I'm going to pick angle 5. Now, if I were to pick angle 1, is there any angle that is adjacent and supplement to angle 1? Well, unfortunately, we don't have any terminology for this angle over here. So 2 plus 3, we don't know what that is. So we want to make sure that we be careful with this diagram. Okay. Linear pair. Linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles of a linear pair form a straight angle or a line. So this is kind of like that last question we just did. What two angles are supplementary and adjacent? That is a linear pair. A linear pair is adjacent here, so they're adjacent, and they form a line, okay? That's why it's a linear pair, pair meaning two. Linear pair postulate. If two angles form a linear pair, then they are supplementary, okay? So if they are supplementary, it does not necessarily mean that they are a linear pair, because remember in our supplementary, these could have a space between them. But if I know it's a linear pair, I know that it's supplementary. So angle 1 is 4x plus 36. Angle 2 is 2x plus 24. Find the measures of angle 1 and angle 2. Well, I know from this diagram that this is a linear pair. So what I can do is I can take this 4x plus 36 plus 2x plus 24. I'm going to add those together, and it's going to equal 180. So I'm just going to do a little simplifying on this side. 4x plus 2x is 6x. 36 plus 24 is 60. And now I'm going to solve it. So I'm going to subtract my 60 over. So minus 60 minus 60, 6x equals 120. And I'm going to divide by 6. X equals 20. All right. That's nice to know. It does not answer our question. Our question was, what are the measures of angle 1 and angle 2? So now I need to take this 20 and plug it back in. Now I'm going to start by plugging it into angle 2. So this gives me 2x plus 24. 2 times 20 plus 24. 40 plus 24 equals 64. Now, the other thing I can do is now to find angle 1, what I can do is I can just subtract this from 180. That actually works. I'm going to plug in just to get a little bit more practice in algebra and that kind of stuff. But you definitely could subtract that from 180. It doesn't matter. It's whatever's easiest for you. Sometimes I find multiplying and adding to be easier. So this is 80 plus 36 or 116. Okay? So there's my measure of my two angles. Angle bisector. So angle bisector is a ray, a segment, or line that divides the angle into two congruent angles. All right? So here's our diagram here. So here we have our blue angle. We have our red bisector. And what that's going to do is split this up into angle A and angle A. So these two angles are congruent. All right? So given AD is the angle bisector here, BAD is 33. So if this is 33 degrees, what is DAC? Now it may not look like it, but because we said it was an angle bisector, this is also 33 degrees. If DAC, so now we're ignoring this first part, DAC is 2x plus 3 and BAC is 54, I know these have to be equal to each other. So it says, what is the value of x? And what is the measure of DAC? Well, I already know the angle of DAC. It's got to be the same as BAD. So this is already 54. Now I just need to find the value of x. So I'm going to go over here and I'm going to go 2x plus 3 equals 54. Okay. I'm going to subtract off my 3, 2x equals 51, divide by 2, x equals 25.5. If you want to leave it as a fraction, that is fine also. You could leave it as 51 over 2. You could write it as a decimal. You could write it as a mixed fraction. It doesn't really matter. All right, why do bees have sticky hair? Because they have honeycombs. And what goes? Oh, oh, oh. Santa walking backwards. So, there's our time together.